Hello everybody. Today we will be talking about concepts regarding charge and charge conversion. As we all know, everything is made up of atoms. Within these atoms, we have three subatomic particles, namely the proton with a positive charge, the electron with a negative charge, and the neutron with a neutral charge. Now these concepts are very important because, as I said, these subatomic particles are charged. Let's say, for example, in an atom's nucleus, we have positive and neutral charges in the nucleus, while in the outside the nucleus, we have the electrons or the negative charges. These charges are free moving, meaning they can easily escape the atom if they want to. However, protons and neutrons cannot escape the atom. We will be needing those concepts again later. Now, first of all, what is a charge? Well, a charge is a type of particle wherein it can have either one of three magnitudes. The first one is positive, neutral, or negative. However, this neutral charge, it's not considered by most people to be an actual charge since it does not have a charged value. Because it's just zero. So as you can see, the positive charge here is the proton in the atom, and the negative charge is the electron in the atom. Now, let's move on to charge conversion. We know that one electron or one free electron in an atom can move about. So we will be using mostly this free electron formula or this free electron conversion. So one electron or one free electron has a mass equal to 9.109 times 10 raised to negative 31 kilograms. And it also has a charge of 1.602 times 10 raised to negative 19 coulombs. Now, these conversions will be very, very important when we go to problem solving. Take note that the charge here will be negative, but in most cases, we can just use the absolute value of this. Now let's move on to one example problem. Let's say that we have a 7 microcoulomb per second current passing through a wire for 2.5 seconds. How many electrons pass through the wire? Additionally, also find the collective mass of the electrons passing through the wire. Passing through the wire during that time. Let me just move my screen down a bit. Okay, so we should take note that the current, symbolizes I, is equal to the charge with symbol Q over time. with symbol T. And we are given that I is equal to 7 times 10 raised to negative 6 since it's micro coulomb per second, and we have time that's equal to 2.5 seconds. So simply, to get the charge, we just multiply this. So it becomes 7 times 10 raised to negative 6 coulombs per second times 2.5 seconds. So we could cancel this. We would get a charge that is equal to 1.75 times 10 raised to negative 5 coulombs. Now, to get the number of electrons passing through, we would just simply divide 1.75 times 10 raised to negative 5 coulombs by 1.602 times 10 raised to negative 19 coulombs per 1 electron. So when we could cancel this. So when we solve this in a calculator, we would get the value of 1.09 times 10 raised to 14 electrons. And finally, to get the collective mass of the electrons, we simply multiply this by the mass per electron. So this becomes 1.09 times 10 raised to 14 electrons times 9.109 times 10 raised to negative 31 kilograms per 1 electron. We would get the value 9.95 times 10 raised to negative 17 kilograms. And those are our final answers. One more thing about charge conversion, about the basics of charge and charge conversion, is that we need to then discuss about Coulomb's law, and that would be the topic for the next video. I hope you like this video, and be sure to like and subscribe and leave a comment down below. It would really help the channel, and I would really appreciate it if you would comment down below what topic you would like me to cover in my future videos.